All right, homework 9.2, we're solving log equations. Some of them are really easy, some of them get a little bit trickier. I'll do a few to make sure you know what's going on. This first one, we've got a log equals a log, and the inverse operation of a log and the work that you need to show is you need to do an exponential. You do 19 to the power of both sides, and luckily it cancels out both logs. That's one of our properties of logs, is that a base to log of the same base cancels out and gives you just the whatever is left over. So we get x plus 8 equals 3x, and we solve and we get 2x equals 8, x equals 4. Cool. We need to make sure that that answer doesn't make the inside of the log negative, because if it makes the inside of the log negative or 0, it's undefined. In this case, we don't need to check anything else, just make sure it's not negative. So 4 plus 8 is 12, not negative. Great. Number 3 I'll do, and then we'll move on to another type. Here, it's not log on both sides, and the log isn't isolated. You need to get the log by itself first. So the first thing to do is subtract 6, log base 11 of negative 8x equals negative 1. And now we can cancel out the log. So we have to do 11 to the power of both sides. Here, log to the 11 to the log base 11 of negative 8x cancels out and just gives you negative 8x. Here, 11 to the negative 1 power. You need to know how to do your exponents here. 11 to the negative 1 power means 1 over 11. Divide by negative 8. And here you have to use some middle school skills. When you have a fraction divided by a whole number, that's the same as the fraction times the reciprocal. And so we get x is negative 1 over 88. All right, let's move on to some slightly more challenging ones. Let's do number 9. Number 9, again, we have a log equals a log, so easy there. 12 to the power of both sides, just cancels out the log. So negative 6 plus 2m squared equals 3m squared plus 5m. This is a quadratic, so we need to make it equal to 0. And I want the m squareds to be positive. Since there's more on this side, I need to move the 2m squared over to make sure I have positive m squared. And so we get 0 equals m squared plus 5m plus 6. This can be factored. M plus 3 times m plus 2. M is negative 3 or negative 2. And we just need to make sure that neither one of these makes the inside of a log negative. So when we put in negative 3 here, negative 3 squared is 9. 2 times 9 is 18. 18 minus 6 is 12, so that's positive. Negative 3 squared is 9. 3 times 9 is 27. 5 times negative 3 is negative 15. 27 minus 15 is 12. It's positive. That one's going to work. Negative 2 squared is 4. 2 times 4 is 8. 8 minus 6 is 2. So that's good. That's positive. And then over on this side, 2 squared is 4. 3 times 4 is 12. 5 times negative 2 is negative 10. 12 minus 2 is, or 12 minus 10 is 2. You know, I guess we only really needed to check one side, because if it's positive on one side, it'll also be positive on the other side. So we're safe there. All right, on the back, we start getting to some more challenging ones. Let's look at number 12. Number 12, we have 2 logs, and it would be nice if we could just move this over to the other side, but there'll be a constant there. So we won't be able to, it'll be pretty tricky if we do that. And I'll actually solve this one 2 ways for you. The first way is using properties of logs. So if we have log of something minus log of something else, we can combine it into a single log of the first thing divided by the second thing. And now we have only a single log. And so we